Okay, so again, in section 12.7, we talked about triple integrals in the last class, and you saw a variety of different problems. Um, and again, you know, finding the limits for triple integrals is usually the challenge that students have. But once you find the limits, doing the integration, I mean, if you can integrate one integral, you can integrate three integrals, right, in a triple integral. But of course, it's always nice to be able to check your answers using technology. And MATLAB is really good for checking answers on triple integrals. So what I want to do is look at this second example. You have a triple integral over a tetrahedron. You want to find this triple integral where E is a solid tetrahedron bounded by the planes x equals 0, y equals 0, z equals 0, and x plus y plus z equals 1. Okay, and of course, they get the triple integral as you see here. Okay, the triple integral, the limits are, the z limits are from 0 to 1 minus x minus y. So that's the bottom plane, and the plane, well, if I actually, hold on, I can be a little more, I mean, this here in figure 5, this, well, hold on, I don't want that highlighted. One moment. Let's see if we can, okay. So in figure 5, this is the tetrahedron, the solid E, and it's bounded above by the plane z equals 1 minus x minus y, and the solid E is bounded below by the plane z equals 0. And then if you project that that solid down into the xy plane, the region D is going to be this triangle here in figure 6. The limits then, the limits for this particular problem are going to be z goes from 0 to 1 minus x minus y, or z equals 0. The limits for z are z equals 0 to z equals 1 minus x minus y. The limits for y, with respect to y, are going to be y equals 0 to y equals 1 minus x. And the x limits will go from x equals 0 to x equals 1. Now they work this out. They do the integration, and they get 1/24. So what I'd like to do is show you how to do this in MATLAB. So on that note, then, let's go to Blackboard, where we have our MATLAB programs. Okay. Let me go into Blackboard. Okay, go to, so incidentally, you know, how many notice, class, that when you open up your Blackboard, you're put right into the course content? How many notice that little change? So it used to be you would be right into class and office hours when you open up Blackboard. But now when you log into Blackboard, into the course, you're put into the course content. Did anybody notice that little change? Okay, Marvelous did, and the reason, and John did, and the reason I did that, and I'll just mention it while I'm here. The reason I did that is I wanted you to be aware that you know, every chapter, if like multiple integrals, chapter 12, if you click on the Here button, okay, you have the sections, and then every section has the lectures. So I put it in a nice organized form for you, okay, and that's why I do that. I mean, of course, I know that you can always go to class and office hours. You can always go there, and if you click on the little menu here with the 3 lines, you click on that, you can go to recordings, and you can see recordings there too. And actually, those recordings are going to be there quicker than the ones in the course content. because those are instant. But I like the course content. How many find the course content helpful just for keeping, for kind of having things organized? How many have looked at lectures from the course content folder? Has anybody done that yet? Okay, all right, good. Robin has, Ryan has, marvelous. Jamal, excellent, excellent. All right, so I just want to mention that, but on that note, let's now get back to the MATLAB programs. So we want to find a MATLAB program that will do. I'm going to click on MATLAB programs. So we want to find a MATLAB program for section 12.7 that will do a triple integral in rectangular coordinates. That's what this triple integral in example 2 from section 12.7 is in rectangular coordinates. So I'll click on MATLAB programs link, click here to see the MATLAB programs, and I go down to 12.7 triple integrals. And here we go. This MATLAB program will demonstrate how to compute a triple integral using rectangular coordinates. Okay, so I'm going to click on this. And what I'm showing you here actually, well, I click on the MATLAB program and it should now download it on your computer. And then if you click on the program, it should open up MATLAB and bring MATLAB up. What I'm showing you here is going to be helpful for MATLAB assignment number 7. Because MATLAB assignment number 7 involves using MATLAB to help you find triple integrals. Okay, so all right, so let me go ahead here and go into MATLAB. Let me bring it up. Hold on, class. Okay, and how many of you have this program right here? How many are, I'll give you a moment to bring it up in your MATLAB. Okay, so how many of you have this program now in front of you on your own computers in MATLAB? Okay, Ryan has it, good. John has it, good. I'd like everybody to open it and look at it, okay? I want everybody to try this program. Maybe one more person has it open. I'll feel better if at least 3 of you have it open. Excellent, marvelous, excellent. Okay, so now you see here in the program, I have a command called clearvars. What clearvars does is, when you create variables, it puts variables in your workspace, and MATLAB has these variables stored in your workspace. Well, I want to use X, Y, and Z. I'm going to use those, and I want to just have them clear. Any old values that were stored in those, I want them cleared out. So that's the purpose of clear variables. Then I use the command sims of X, Y, and Z. Sims X, Y, and Z. What that does is it creates symbolic variables for X, Y, and Z. Okay, because I'm going to do integration here. All right, and now it's a trick. You like on this line here, int. What does int stand for, class? In MATLAB, what do you think int stands for? Integral. That's right, Ryan. So I'm doing a triple integral, but I have to nest the integrals inside each other. Okay, so like for this particular problem, Well, first of all, I define my function f, my integrand, to, well, it equals z. In this problem from example 2, section 12.7, the integrand equals z. Okay, but sometimes the integrand can be complicated, and I don't want to, down here in my, when I do my integration, I don't want to have my f formula. I don't want to have to write out a big long f formula, but the function there. I don't want to write the function there because it for one thing, it makes it kind of long, the formula or that command line. It makes the command become long and kind of unwieldy to use. So I just define my integrand right here. Let f equals z in this case, or that's, for example 2. That's what the integrand is. That's what the function is. F equals z, and then all right. So now I have here an inner integral. Okay, right here. Let me just see here, right here. And what that says is, all right, MATLAB, I want you to integrate the function z with respect to z. That's what that, you have f comma z. The z there means integrate with respect to z, and use the limits going from the bottom limit z equals 0 to the top limit z equals 1 minus x minus y, top and bottom surfaces. Now what's going to happen is MATLAB's going to store that, right? It's going to integrate that and store that, and you're going to have a function now. You're going to have a function of x and y that you need to integrate. So now what you do is you then say, okay, well, now I'm going to integrate that function of x and y with respect to y. Okay, hold on here. I guess I can't, I don't know if I can highlight it both. Well, yeah, I mean, this is the second integral, and I'm integrating a function of x and y with respect to y. What are the y limits? Okay, well, based on region D, the bottom function is for that triangle. The bottom function is y equals 0. The top function is y equals 1 minus x. And then finally, for the last integral, okay, the last integral here on the outer integral, the last integral, I'm going to integrate, well, after I integrated with respect to z, I had a function of x and y. And then if I integrate a function of x and y with respect to y, I'll be left with a function of x. Okay, and so the last integral I integrate with respect to x, and the limits based on the triangle in example 2, that would be figure 6 from example 2, the x limits are 0 and 1. Okay, so you can take this code, you can copy it, and you can go to the command line here, paste it, hit enter, and there's the answer. The triple integral has a value of 1/24. Okay, how many think this could be very useful in helping them with their homework, helping you confirm your answers? How many are going to use this? Okay, John's going to use it. Who else is going to use this to help you? Ryan, wonderful. So of course now, you want to, and Jamal, wonderful, wonderful. So, you've done, I mean, we want to be careful, of course. I don't want you to not work the triple integrals out by hand, because it's an important skill to be able to do triple integrals by hand. But I also think it's important to be able to check your answer in MATLAB. I think that's useful too. Certainly for your next exam, right? It'll be helpful to check your answers with the MATLAB. So I wanted to show you this program, and I hope you find it helpful. I hope you find it helpful. Are there any questions? Okay. I want to mention class 2, you know, on the command line, if you ever want to clear your screen, just type CLC, and that should, well, CLC, yeah, just hit CLC and it should clear your screen. I didn't know if you knew that. Okay, let me stop the recording on this.